Okay, hi to everyone. So this is a Sunon Mighty Mini fan, which is 8 by 8 by 5 millimeter, 8 millimeters thick and 8 millimeters wide and 5 millimeters thick. And on its left is a tiny transistor. This is pretty standard through-hole transistor. This is pencil head, and the diameter of the fan, internal diameter, the rotating part is around, let me just figure that out real quick. Yeah, it's around 4 to 5 millimeters wide. Think about it, the standard LED is around 6 millimeters wide. So yeah, that's a pretty tiny little thing. I'm gonna shut up now and power it on so you can hear how it sounds. Don't know if you can hear that, but it is running. And if I just do this a little bit, zoom out and focus, there we go. That's how tiny it is. So yeah, that's the fan actually running at low RPM, since it does have some sort of a temperature sensing things inside of itself. It's single integrated chip for everything, for H-bridge, for Hall effect, and for temperature, and for PWM output for the RPM. So if I just try to strike a match and shut it off quickly, so it produces a lot of smoke, and when the fan sucks the smoke in, it actually picks up the speed because it gets warmer. So it's actually temperature controlled. It runs of 3 volts, so I connected 2 AA batteries in series for this test and simply placed it on its SMD connector. So I'm gonna just plug it off and I'm gonna show you around it. This is it. Sunon. This is the back of the fan. This is some part number. You can search it up, but all information about this fan are easily available. Just search for Sunon Mighty Mini 8 by 8 by 5 and you will get all information you need about it. So I'm gonna start disassembly, and you're gonna see what's inside this little thing. Okay, so as you can see, this is focus. This is the main rotor. As you can see, it has the plate, and that plate, if I can flip this around, that plate fits inside the ridge of this plastic housing like a button. It fits snugly enough to not fall out, but you can literally just push on the center hub of the fan and everything will just come out. And you can see, oops, you can see the coils that are outside of the fan. There are two, one in this corner, one in this corner, and back here is a Hall effect sensor with all those integrated stuff. And this little ridge that you see here are little ball bearings. Those little ball bearings are used to put the rotor into a starting position when once it shuts off. So there we go, that's the rotor. You can see, if I can just flip it, that there is a ferromagnetic ring outside the fan, and I checked it. It's a 6-pole rotor, so you will get 3 PWM pulses per rotation of the fan, And pay in mind that this thing spins around 11,000, 12,000 RPM when it's running, so it's pretty fast, but you still can't really feel any airflow or any pressure, since it's just such a tiny fan moving such a tiny amount of air. Okay, now I just slid the rotor off of the bearings. You can see it uses small brass bushings, oil bushings, and you can see this ring around that is used to hold the rotor in place, since there is no axial holding system, there is no retainer pins or anything. It's just attracted by this metal ring to stay in place, otherwise it would just by air pressure it would just slide up and get stuck in the housing. Here you can see the casing. I pulled the coils out. They just slide right in. It's like one tiny integrated unit. As you can see, these are the coils. If I find the camera, there we go. As you can see, there is one coil there. If the thing calms down, there is a second coil there. And if I flip it, you can see that little chip, and that's the only chip on this entire thing. So there is really no point in making circuit diagrams, since it's just two coils going to a chip and two inputs, positive and negative, and one output for the PWM signal. Nothing really special, no resistors, no capacitors, nothing. Just bare chip and two coils. So yeah,